Hello again, everybody. This is Tom from Every Step Physics this time, and Every Step Calculus too. Don't forget my calculus programs. EveryStepPhysics.com. You buy my programs and you get instructions on how to put the physics here into the entry line here. Open and close parentheses on the end means that it tells the calculator that you want to do a program. And so you have to press second alpha to get the letters come in here all the time, and then you can press alpha to get in the open and close parentheses. Another easy way to do that would be to I go to second and then the minus sign, which takes you into the programs, and then I go to 1 here, which is Q, which brings you under the alphabet for physics, which we want to know. And then you can scroll up to physics here and press enter, and then add the right parentheses, and then you're ready to go. You don't have to, but like I say, if you press alpha, it'll put the letter in once. If you push second alpha, it'll keep putting the letters in instead of the numbers. And the letters are, of course, over the numbers here on your titanium. So let's do this problem here. This is a ramp physics problem, and the way I do it, remember I did these for my tests, so when they asked me for acceleration, then I went to acceleration. If they asked me for tension, I went to tension. Whatever they ask for. Here they ask for acceleration and tension, so generally I try to put that into the same program. So we'll screw down here to acceleration, press enter. And then this is angular acceleration, this is centripetal acceleration, and then we don't know. If you don't know, then it might go to here. I don't know where I did program that to, but we can find out. But let's just do the problem first. So we have M1 and M2 in this one. So let's choose that one. And then we're asked for what's given. And you'll scroll down here to, this is only one mass times force, and here's one mass times force times kinetic coefficient of kinetic friction, and then static friction. So whatever they give you in the problem here, generally what I do is that you get a problem like this, right away if two blocks are connected over a massless pulley as shown, the mass of the block M1 is 6 kilograms. So you put M equals 6 kilograms here on the side on your paper. And the mass of the block 2 is 15, so you put M2 is 15 kilograms. So you got one mass and the second mass. And the angle, you put the theta down here, the abbreviation for angle is theta. And there's theta 1 is not equal to 30 degrees, and then theta 2 is equal to 50 degrees. And then you have the UK, which is 0.6. So then you got it all listed here so that you know that you're supposed to get M1 and M2 here, and then two angles. So we scroll down here and keep going. And here's M1, M2, theta 1, theta 2 on UK. So that's the one. If you had to do it a lot of times, you can just press the T here, or before the selections here. So let's press enter here. I'll tell you what is ramp with two angles, two masses, and coefficient of kinetic, etc. I show you what the problem looks like a little bit, as best I can on the screen here of the titanium. We're going to enter the mass. Well, here's M1, so we're going to have to press alpha first. Remember that you got to press alpha first, and then you can put the numbers in. So alpha 6 kilograms. Notice I do the conversions for you. If they gave you it in newtons, then it would turn it into kilograms, because all problems are done with kilograms. Make it easy. Remember, I did these for myself, so I want to make it as easy as it could for myself to pass these tests here. Second mass is alpha 15. kilograms. The angle is alpha 30. Second angle is alpha 50. And the coefficient of friction is alpha 0.6. I'll show you what you've entered so you can change it in case you made a mistake. 6, 15, 30, 50, and 0.6. Looks pretty good to me, so we'll say it's okay. And we're into the problem. This is the net force, the total force of the system. That's what I always like to give the abbreviations proper meaning. Here's the force of gravity 1, and m1g sine of theta 29.43 adds all the things. Here's the normal force for m1. m1g times cosine of theta is 50.974. Here's the friction force, which is the coefficient of kinetic friction here times the normal force, 30.585. And this turns out to, when we put these numbers in here, here's the force of gravity, here's the friction force, and of course m1 is 6. And this is the first equation here. And then we do the same thing for the other side, for the other mass, m2. And the normal force for m2. Friction force. Second equation. Now we subtract the 1 second from the first here. Come up with minus 404 equals 21 times acceleration. When we do that, it turns out to be this. When we divide the sum of the masses into it, 0.193. It's for acceleration. Now we want to find the tension. So here's the formula here. Fg x2 minus Ft is equal to the mass times the acceleration here. Write all this exactly down in your paper. And it says when we do the calculations and everything, it turns out to be 58.859 newtons. Pretty neat, huh? Every step physics.com. Go to my site, buy my programs, and pass physics. You can call me up too. I'll help you all I can with physics or whatever you need for the programs or whatever, you know. If there's a problem that is not in here, which then you can call me or email me and I'll program it for you quick. So I'm interested in you passing physics, and it's a tough course, let me tell you. So this calculator is the greatest thing ever. Have a good one. Well, you can do the answers again too if you want. You can go back and look at the answers again. I've programmed that in for myself. And we say no, then we can go back and do no problem. We can go back to the main menu, etc. So have a good one, okay? Good luck in your classes. Don't forget my calculus programs either.